Okay, so today's the last part of graphing trig, and we're going to be learning our horizontal shift and our vertical shift. Okay, but it's a little bit different. So translations of sine and cosine curves. So the constant c in the general equation that they've given us, or we're actually used to seeing it as h in our other parent functions. So you could either write it as c, or you can think of this as h, because at the beginning of the year, when we talked about our transformations and we gave you this generic function like this, with all of our transformations, we use a, b, h, and k because of the quadratic, the vertex being at hk, where h is your horizontal shift and k is your vertical shift. Okay, but in trig, most of the time, textbooks and formulas use c and d. Okay, but c is basically h, and d, we'll talk about in a minute, is our k. Now, this creates a horizontal shift to the left or right for the basic sine or cosine curves. So if you compare sine with bx versus sine of bx minus c, the graph completes one cycle from bx minus c equals 0 to bx minus c equals 2 pi. These two equations right here basically tell you, with your change in period and your shift, where that original period is going to either start or it's going to stop. So this is telling you where your new function is going to start, and this one's telling you where it's going to stop. Okay? Now, we don't always have to use those, okay, but it is an equation that you can use to find where it begins and ends. Okay, if that's all you're looking for, where it begins and ends, that's what you can use. Now, to find the interval for one cycle, you could always solve this equality. Okay, so this is another way of doing it, to find out that one cycle or period, where 2 pi over b is the new period and c over b is the phase shift. And we'll talk about this phase shift in just a minute. Okay, because the phase shift is the amount of the graph is shifted relative to the period. Okay, and what that means is, and this is the first time we've kind of had to deal with that, is that if you had something like this, my f of x equals sine of, say, 2x minus 2 pi. Okay? If I said, what's my horizontal shift? Okay? Most of my students would tell me that it's going to be to the right, because we have that minus 2 pi there, and they would tell me we're going to the right 2 pi. But that's not the case, because we have a phase shift. We would go over 2 pi, but this right here changes my period. It is a horizontal compression. So what it in effect does is it actually compresses everything horizontally, including my shift. So instead of my shift going over a true right 2 pi, then the actual compression is going to compress that 2 pi down to pi. Okay? And the way to really see your true horizontal shift is to do this. Take out that 2 and have this just be x. And when you take out your common factor of 2 from both, you can see, and I'll put these in brackets so you can see it. When I take that 2, that change in period out of both of them, you can see that it actually only moves to the right pi. Because the horizontal compression, not only does it compress my wave, it compresses my shift as well. And that's what we mean by a phase shift. Okay? But we'll talk more about those next week. Okay? Now, the last transformation is, of course, our vertical shift. And that's right here. That's d. Or, again, if you remember the transformations before, that's what we also call k. Okay? So this could be written as d or k. Not Donkey Kong, but d or k. Okay, so that vertical shift, we write it at the beginning of the trig function instead of at the end, so that we don't get it confused, very similar that we did for the exponential and the logarithm. If that k is just hanging off the back end and there are no parentheses around the cosine x, it might be confused as a horizontal shift. So that's why we generally write it at the beginning, so there's no confusion. Okay. Now, that vertical shift also deals with our center line. Okay. And the center line is that midpoint between the maximum and the minimum. It's that imaginary line that moves with the vertical shift, and it's where the original zeros of the function end up. And it's located at y equals d or y equals k, depending on which one you like to use. Okay? So normally the center line, if there's no vertical shift, is at 0. But if it's gone up or down, it follows my vertical shift. Just like what we did when we did the parent function for the reciprocal function. If it was moved up, that horizontal asymptote moved up or down with the function. Same thing with our center line. It moves up or down with our function. Okay? All right, so let's practice a horizontal shift. Okay? So we're going to be sketching y equals 1/2 sine x and y equals 1/2 sine x minus pi over 3. Okay? So first thing I'm going to do is this is my y-axis, this is my x-axis, 0, and then mark off every 3 like I did the last time. Okay? So this is pi over 2, this is pi, 3 pi over 2, 2 pi, 5 pi over 2, so on and so forth. Okay? And again, before I draw any transform function, I draw my parent function first. Since I'm dealing with sine, sine starts at 0, 0, then is at pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. So my parent function looks like this. Okay? So I'm going to be using 2 different colors to show my different transformations. Okay? So there's my parent function. So my first color I'm going to use, and I'm going to do that. Because I actually have 2 transformations I'm going to do. First, I'm going to do any kind of vertical stretch or compression first whenever I transform trig functions. I start with my horizontal stretch or compression, then I do my vertical stretch or compression, then I start moving left to right, up or down. Okay? Very similar to what we did when we did regular polynomials. So this is a change in my amplitude. Okay? So this is my vertical stretch or compression. Since it's 1/2, it's telling me my new amplitude is 1/2. So this is a vertical compression. So my zeros are exactly the same, but my maximums and minimums are now at 1/2. So here is my first transformation. Okay? Now, I'm going to do my second transformation with red. And basically my second transformation is exactly what I did, the 1/2 sine x, but now I've got a horizontal shift in it. And it says x minus pi over 3. Okay? So basically, the reason I marked off my x's into 3's is because just like the unit circle, when you divide up the first quadrant into 3 equal pieces, that means this is pi over 6 and this is pi over 3. So basically what I've done is I've set myself up so that I have to move everything over to pi over 3 to the right. So all I'm going to do now is this, I'm going to move over 2 boxes, 1, 2, to this is pi over 3. And then this one I'm going to move it over 2 to here, this one over 2 to there, this one over 2 to there, and this one over 2 to there. And this is my final transform function. So basically nothing's changed from what we've done before with shifting it left, right, up, or down. The only difference is it's going to look ugly to you guys because you don't like fractions. And since our unit circle radians are all fractions, that's what's going to cause you to have problems. Okay? But there's an example where we've done two transformations. One, a vertical compression, and then a horizontal shift to the right, pi over 3. Okay? All right, so let's just practice without graphing, just finding components of our trig functions. Okay? So the next practice part is basically just giving an equation and you finding the pieces of it. Okay? So for each trig equation, find the period, centerline, amplitude. And again, we're going to be using this a f of bx minus h plus k to kind of give us that, well, which is which letter? Well, I guess in this case, we could write it so that it matches our trig a little bit better as k plus a function, whatever it is, sine or cosine. Okay? So when we compare it to what we've got, so let's look at the first one. This -2 right here, that's my k. And from what we've been talking about, k is my vertical shift. So that tells me where my center line is. So where is my center line? Y equals -2. Okay? Next, this 2 right here, that's my B. So that's telling me I have a change in my period, horizontal stretch or compression. So my new period is going to be 2 pi over B, and since B is 2, it's 2 pi over 2. So my new period is pi. So the length of my curve is pi. And then what is my amplitude? Do I have a change in amplitude at all? Nope, because A is right here in front of the cosine, and since A is not there, it's just 1, so my amplitude is 1. That's it. Okay? So let's look at the next one. Again, let's look at this -1. What does this -1 outside the parentheses represent? My center line, my vertical shift. So where's my center line at? Yep, y equals -1. What's my amplitude? Because that's the next easy one. Do I have a change in amplitude? Nope, because there's no number in front of this sign. So my amplitude's still 1. Now we need to find our period. So period equals 2 pi over b. And in this case, this is one of those times where you need to switch this. So this is sine of 1/3 x minus 1, because dividing by 3 is the same thing as multiplying by 1/3. So b is 1/3. So we get 2 pi over 1/3, or 6 pi, because dividing by 1/3 is the same thing as multiplying by 3. So my period, 6 pi, which means that is a horizontal stretch. Okay? All right, let's look at the next one. So let's see, what does this 3 represent? That my vertical shift. So that's my center line at y equals 3. What is this 1/2 right here? Amplitude. So my amplitude is 1/2, which means it's been vertically compressed. Do I have a change in period? No. This right here, this is my horizontal shift. So there is no change in period, which means my period is still just 2 pi. So this is a horizontal shift. not a change in period. Okay? All right. So this 4 in front of the sine, that is my amplitude. So my amplitude here is 4. It's been vertically stretched by a factor of 4. This 8/3, that's my change in period. That's my horizontal stretch of compression. So that is B. So period is 2 pi over 8/3. Dividing by 8/3 is the same thing as multiplying by 3/8, which gives me 3 pi over 4. Yep, 6/8, which reduces down to 3 pi over 4. So my new period is 3 pi over 4. What is this right here? That's my horizontal shift. So it's been moved to the right 6. So where is my center line? Right where it started, at 0. It's not been shifted up or down, so it's still at 0. And the last one, so this 5 right here, that is my vertical shift. So that's where my center line is, at y equals 5. This 2 right here, that represents my new amplitude. So my amplitude is 2. And this 8 right here, that's my change in period. So period equals 2 pi over 8, which reduces down to pi over 4. So this is a horizontal compression. It's made it smaller. And again, I don't need to know anything about the function. We haven't talked about graphing secant, but if I needed you to graph that, you would at least know what the transformations are, no matter what the function is. Okay? Because the transformations stay the same no matter what. All right. So let's put it all together and let's graph this. Okay? So it says sketch this function and its parent function. Okay? So again, basically we're going to set it up just like we did the last time. So this is your y-axis, this is your x-axis, this is 1, this is -1, this is 2, this is -2, and then every 3 marks, that's going to be pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. Okay. And again, we should always graph our parent function first. And in this one, it's our cosine. So using our unit circle values, at 0, cosine's 1. At pi over 2, it's 0. At pi, cosine is -1. 3 pi over 2, it's at 0. And at 2 pi, it's at 1. So this right here is our parent function. All right, so let's look at what kind of transformations. Just like we did before, I'm going to look at the different pieces. So this right here, that means that I have a vertical shift. So my center line is at y equals 1. So it means it's been shifted up, right? This right here, that's telling me my new amplitude. So my amplitude is 2, which means I have a vertical stretch. This number right here, that is my change in period. So my new period is going to be 2 pi over 2, or pi, which means I have a horizontal compression. Okay? And that's where we're going to start first. Okay? We're going to start with that horizontal compression. Always start with your horizontal compressions or stretches first, then go to your vertical stretch or compressions, and then move to your shifts. Okay? So since my new period is pi, I know that it still starts at 0, but now this whole wave ends at pi. So this has been compressed all the way to here, to pi. Everything's been divided in 2, which means pi has been divided to pi over 2. And then my zeros are going to be here at pi over 4 and 3 pi over 4, right in the middle of my maximums and my minimums. So here is my horizontal compression. Like that. Okay. Do we still see a full cosine wave? Yes. Is my minimum right here at pi over 2 still halfway between my 2 maximum points? Yep. And my zeros are halfway between my maximum and my minimum on both spots. So remember, we can kind of use midpoints here, kind of talking about it to make it easier on us. All right, next, I'm going to do that change in amplitude. I'm going to do the vertical stretch. So now what's going to happen is all of my maximum minimums are now going to be at 2. So my zeros on this one are going to stay in the exact same place, but this maximum is now going to be up here at 2. And my minimum is going to stretch down to -2. And this one's going to be stretched up here to +2. All of my y values are multiplied by 2. Or think of it as your maximums and minimums are now at 2 and -2. So this one's a little more difficult to draw when you got this giant stretch. Okay? Now, the last thing we're going to do is deal with that center line, because my new center line's at 1, which means everything's been shifted up 1. So basically all of these, and this is going to kind of go off the graph, but this point here is going to be shifted up 1 to here. This point here is going to be shifted up here. This point here is going to be shifted to here. This is going to come off the graph. It's probably going to be somewhere like right here. And this one will come off somewhere right there. So the last part, my transformation, is basically here. And this is at 3. This one finishes at -1. And I'll show you something. We said my center line was right here at 1, correct? And we knew my amplitude was 2. If you remember what amplitude is, it's the distance from your center line to your maximum and the distance of center line to your minimum. So if my center line's at 1, that means my maximums have to be 2 away, which is at 3 and -1. And is that where I ended up? Yeah. So that's another way of thinking about it. If you know where your center line is and you know your amplitude, you have a good idea that you know your function is going to exist between this point and that point, and the middle should be right there at 1. So it's a way kind of to check your work. Okay? And we'll practice more of these tomorrow.